So the problems in helical spring, a closed coiled helical spring of mean diameter 20 centimeter is made of 3 centimeter diameter rod and has 16 turns. A weight of 3 kilonewton is dropped on this spring. Find the height by which the weight should be dropped before striking the spring so that the spring may be compressed by 18 centimeter. Take C as 18 to 10 power 5 Newton per millimeter squared. So the first step is given data. During given data, you can convert the values in terms of millimeter and loads in Newton. So here the mean diameter of the coil is given as 20 centimeter, which is 200 mm. Then mean radius of coil is 200 by 200 mm. Then diameter of spring rod is given as 3 centimeter, that is small d. So spring diameter and total coil diameter. Coil diameter is that spring's outer diameter is coil diameter. The spring itself is having a small diameter and which is spirally formed. So that spring small diameter is small denoted as diameter of the spring in small d notation. So number of turns n equal to 16. Weight dropped W equal to 3 kilonewton, 3000 Newton. So compression of the spring, that is stiffness, equal to 18 centimeter. So that is 180 mm. So modulus of rigidity C equal to see, compression of the spring here is deflection 18 centimeter, that is 180 mm. Modulus of rigidity C equal to 8 into 10 power 5 Newton per mm squared. H equal to height through which the weight W is dropped. W equal to gradually applied produces the compression of spring equal to 180 mm. You know that the deflection equal to 64 W R cube N divided by C D power 4, which is a formula. So this deflection is given as 180 mm, and so you can substitute the values with respect to this formula. So 64 into W into that R is 100 cube and N number of turns is 16 divided by C, modulus of rigidity 8 into 10 power 4 and coil diameter 3 centimeter 30 mm per power 4. From that you can get weight. And we know that work done by the falling weight on spring. So there has some weight which fall on the spring. So that is equal to weight falling into, that is weight falling is the product of weight that height plus that deflection. So weight falling is 3000 Newton into that H plus the deflection 180. So and energy stored in the spring, that is strain energy stored in the spring is half W into deflection. So half into that W, which we find out using the spring formula, which is 11390 into deflection, which given in the sum is 180. So that gives a value of 10,2500 Newton mm. Now equate the falling weight on the spring to the energy stored in the spring. So there have a equation we have to form with respect to this weight, that is work done by the work done equal to energy stored in the spring. So work done 300 into within bracket h plus 180 equal to that energy stored in 2500. From that we can get the height from which the weight was fallen. Okay, that is h equal to 161.7 mm.